Hello everyone, today we'll be doing the topic of discriminant. So the discriminant is equals to b squared minus 4ac. The discriminant applies for any quadratic equation in the form ax squared plus bx plus c equals to 0. If b squared minus 4ac is more than 0, this means that the quadratic equation has two real solutions. If b squared minus 4ac is equal to 0, this means that there is one real solution. And lastly, if b squared minus 4ac is less than 0, this means that there are no real solutions. So you may be wondering, why does the discriminant work like this? You may find b squared minus 4ac to be pretty familiar. This is actually part of the quadratic formula. And actually, why the discriminant works is totally based on the quadratic formula. If b squared minus 4ac over here is more than 0, this means that you get negative b plus minus some positive value, so there will be two roots. If b squared minus 4ac is equal to 0, you just get negative b plus minus 0, which means there's only one root, negative b over 2a. And finally, if b squared minus 4ac is less than 0, this square root cannot exist because you cannot square root a negative number. So there are no real solutions. If you are HL, this means that there are two complex solutions. Okay, let's solve a question. Find the range of values of k for which the line y equals to kx plus 3 intersects the curve xy plus 20 equals to 5y. Well, it may not be too clear how we're going to use discriminant for this, but let's simplify this curve. The curve xy plus 20 equals to 5y. So let's isolate the y onto one side. We have 5y minus xy, which means that y equals to 20 over 5 minus x. That's the equation of your curve. And we know if y equals to kx plus 3 intersects this curve, which is basically this, that means we can equate the y together. So we can take kx plus 3 equals to 20 over 5 minus x. So now how do we simplify this? I'll just take kx plus 3 times 5 minus x, which will be equals to 20. And if I simplify this, this will become 5kx minus kx squared. I'm just doing rainbow expansion by the way, plus 15 minus 3x equals to 20. So what this equation on top means is that kx squared plus 3 minus 5kx plus 5 will be equals to 0. We have transformed these two curves into this quadratic equation over here. So for the two graphs to intersect, this means that there's either two real solutions or one real solution. That means that the discriminant is more than or equals to 0. These two real solutions in the case of this question just means that the curves intersect at two distinct points. And over here, it means that the curves intersect at one distinct point. So finding the discriminant for this quadratic, we'll find out what values of k will these two graphs intersect. So we write, since the discriminant is more than or equals to 0, and what we want to find out is what b squared minus 4ac is. So in this case, with a quadratic equation in terms of x, b is 3 minus 5k, so we have 3 minus 5k squared minus 4ac. In this case, a is k and c is 5. So we'll have 4k 5. And if we simplify this, we get 25k squared minus 50k plus 9 is more than or equals to 0. Factorizing this quadratic, we get 5k minus 9, 5k minus 1 is more than or equals to 0. Okay, how do we solve this? This is a quadratic inequality. Let me draw this graph over here. The two roots of this quadratic equation over here is k equals to 1 over 5 and k equals to 9 over 5. So if you want to find out what values of k will make the quadratic more than or equals to 0, we look at the roots. For this part and this part, the quadratic is more than or equals to 0. So the corresponding k values will be k is more than or equals to 9 over 5 or k is less than or equals to 1 over 5. And so that's the range of values of k that we're trying to find. K is less than or equals to 1 over 5 and k is more than or equals to 9 over 5. Before I end the video, I want to go over one more thing. Let's say I have this question. Find the values of k for which 2x squared plus kx minus 3 is more than 0. In this case, would the discriminant be more than 0, equals to 0, or less than 0? Your answer will be the discriminant is less than 0. So why is the discriminant less than 0? If you look over here, the value of a, or the coefficient of x squared in this quadratic, is positive, which will mean the graph will be a U-shaped graph. So what does this mean? If I have this quadratic over here, it has to be more than 0, because that's what the thing says. It has to be more than 0. So it has to be over the x-axis. And if it doesn't touch the x-axis, this means that there are no real solutions. And hence, if there are no real solutions, we get that b squared minus 4ac has to be less than 0. This is just something to note. Here's the summary sheet for discriminant. Thank you so much for watching.